Hello and welcome back to Friends of Tracking. My name is Laurie Shaw and I'm a researcher at Harvard University, where I'm also a member of the Sports Analytics Lab. This is part 4 of a series of lessons that we're putting together on how you can get started working with tracking and event data in football. Now, in this lesson, we're going to take a first look at a new data set. It's a data set that's been kindly provided by Metrica Sports. And it includes not only event data, like we've seen in the previous lessons with David, but also tracking data. Now, just to remind you, there are essentially different types of data in football. Event data is a log of each on-ball event. So that includes passes and tackles and shots, when they occurred in the match, where they occurred on the field, so the start and the end location of a pass, or the location of where a shot was taken, as well as the players that are involved. And so typically this results in about a few thousand events per match. But it only records on-ball activities. So we don't know anything about sort of where all the other players were when they weren't interacting with the ball. Tracking data, on the other hand, provides a almost continuous measure of the location of all 22 players on the field, as well as the ball, sampled at 25 hertz, which means that we get essentially 25 observations per second of their positions. But what we get now is a sort of a much more complete picture of what's going on in the field. Rather than just sort of the on-ball actions, we now know where all the players were continuously throughout the match. And this sort of typically produces several million observations per match, so about 1,000 times more than the event data. And so, as I said, Metrica Sports have kindly made a sample of data publicly available for us that we can share with you. And so over the next few lessons, we're going to take a look at some of the things that we can do with this data in combination with the event data that they also provide. And because we want to make this course as hands-on as possible, you can download the data yourself at this link here. So the main goal for today is to familiarize you with this new data set, and in particular, to introduce you to working with tracking data, and how we can combine tracking and event data to gain a sort of much more complete picture of what's going on at any given moment of a match. So the data for this lesson can be found at this link here. It's a GitHub repository created by Metrica. And the code for this lesson can be found at the Friends of Tracking repository in the Laurie on Tracking directory. So let's click on this link and just take a look at downloading the data. So here is the repository that contains the data. You can see that there are essentially 2 directories. One contains some documentation about the data, and the other contains 2 folders, each of which contain a sample game. And you can click on this green button and download the data by selecting this option here. Once you've done that, let's look at let's take a quick look at what this data actually looks like. Okay, so I've downloaded the data and unzipped it, and what we find is there are two sample games. And I should say at this point that the data has been anonymized, so you won't see any team names or players that you recognize. So let's take a quick look at what the data actually looks like. Let's look in sample game number 1. So we see that there are 3 files. There is one file in CSV format for the events data, and then 2 files for the tracking data, one for the away team and one for the home team. So let's fire up Spider. I'm going to do all the Python analysis in Spider like David did in the last couple of lessons, and let's look at reading in this data and seeing what we can do with it. So here we are back in Spider. So there are three windows. Again, on the left-hand side, we have some of the code that we'll go through today. We can execute that code in the IPython console here. And then up here, we have the variable explorer, and we'll see data and variables appear as we read it in. And there are essentially three files that we're going to look at in more detail. The first one is called lesson 4, and it's just a Python script that's going to kind of step through that's going to go through step by step some of the things we're going to look at today. And then there are two modules that I've written. One is called Metrica IO, and it's the IO stands for input output. And this is dedicated, provides some dedicated functions for reading in the tracking and event data and sort of doing some simple manipulations to get it into the format that we need to start doing analysis. And then the second file is called Metrica Viz, just provides some functions to help us plot the data. So you can see at the top of the first one here is plot pitch, similar to the plotting routines that David showed you last time. So the first thing that we need to do is just set up the path to the directory in which the data is stored that we want to load up. So I'm going to set a string called datadir that just tells Python where to find the data that we're going to look at, the sample Metrica data. And so going to set a game ID equals 2. And this is just saying that we're going to look at the sample match number 2. Okay, so the first thing I want to do is to read in the events data. And so you can see here that I've written a sort of a little function for reading in the event data called read event data. It's stored in the Metrica IO module. So let's go and take a look at that. So here is read event data. And essentially what it does is it first sort of sets up the name of the file that we want to read in. So let's just click and run that line of code. So if we look at what that says, it just gives you the file name of the event data we want to read in, and then we're going to first we need to import pandas because we're going to read in this data as a pandas data frame, and now let's read in this data into the data frame. There we go. And so you'll notice that the event data has now appeared in the variable explorer up here. So let's take a quick look at it, see what it looks like. Let's remove the background colors. We don't need those. And so, as we saw in TextEdit, what you see is there's a set of rows. Each row is a separate event. We now have the index, which allows us to basically gives us sort of an ID or a label for each of those rows. And then we have a column for the team in possession, the type of event it is, subtype, the half, the time here is in seconds. And then over here, we have the sort of start and end location of the event. So for example, event index number 1 is a pass. And so we have the start and end location. So what kind of information is in these in the event file? So what we can do is we can look at the type field, which kind of tells you what kind of event it is, and sort of look at the different events that have occurred in this match. So here, the value counts just kind of shows you the number of each type of event there is in the event file. So you can see for example, there were 964 passes, 311 challenges, 24 shots, some of which will have been goals. So now one thing that you may have noticed when we looked at the event data is that the positions of each event all look very small. They're all basically numbers between 0 and 1, unless one of them happens to occur off the field. And the reason for this is because of Metrica's coordinate system, where essentially they define that sort of the length of the field as being 1 unit and the width of the field as being 1 unit, and the origin is down in the bottom left-hand corner. And now, because it's easier, or at least I find it easier to work in a coordinate system in which things are, the distances are in sort of more recognizable units like meters or yards, so that we can go on later on to calculate quantities like player speed in meters per second, or the distance of a shot from goal in meters. One of the first things we might want to do is change the coordinate system to something that's more easy to work with. And so what I'm going to do is switch to a new coordinate system in which the length of the field now is in meters, 106 meters. The width of the field is 68 meters. And they set the origin in the center of the field. So the top right-hand corner is given as sort of x equals 53 meters, y equals 34 meters, and the other corners correspondingly. And so the way that we change the coordinates is I've written a little function that does that quite quickly. It's here. It's called to metric coordinates. And so essentially what it does is you can pass it in some data, and this data can be either the event file or the tracking data file when we come to read that in. And it'll just convert all the positions such that they're all now in meters, and such that the origin or the center of the field is position 0, 0. And so the way this does this is it just kind of goes through the data frame and finds anything that looks like a position. So in this case, it's anything that any column header that ends in X or Y, and then does the sort of the position transformation. So let's run this line of code and switch change the coordinate system. Actually, first we'll need to import these two modules. So just run that, and then run this. So now if we look at the event data, we'll see that the positions have now changed such that they are, they're all essentially in meters. Okay, so let's look at the events for the home team and the away team separately. So here we have two lines of code in which you see what we're doing is essentially selecting those events in which the home team was in possession of the ball, and those events in which the away team was in possession of the ball. And you've seen this sort of methods of slicing and dicing data frames in the previous lessons with David. So if you run those two lines, so now we have a data frame for home events. If we look at that, so now these are all the events in which the home team was in possession, and then correspondingly one for the away team. And so let's look at sort of the types of events that each team had. So, for example, this shows you that the home team had 543 passes and 13 shots, whereas the away team, if you summarize this data, had 421 passes and 11 shots. Okay, so let's now dig in a little bit deeper into the shot data, and so we can select the shots for both teams by looking for all events of type shot. So let's take a look at the shots data in the variable explorer, and of course you can see these are all shots now for either team. And let's also just create separate data frames for the home team shots and the away team shots. Now, in the shot data, you can see that the type is the shot, but then there are different types of subtype. So this gives you a bit more information about the shot. So in this case, the shot was blocked. The second one was on target, and it was a goal. So let's now look at some of the, how frequently these different types of subtype appear in the data. We can use the value counts method. So you can see, for example, the home shots, they had 4 headers that were off target when out of play, 4 shots that were on target and they were saved, and probably most importantly, 2 shots that were on target and produced a goal, and 1 header that was on target and produced a goal. Whereas for the away team, we can do the same thing, and we can see that they scored 2 goals in this game, both with the feet. There's a separate subtype for headers. And we can also look at which players took shots as well. So here, rather than looking at the subtype, we can look at the from field. And so this is essentially the player that took the action. The to field would be the player that received the ball in the case of a pass. So you can see for the home shots, player 9 took 4 shots, player 10 took 3, player 5 took 2, and the others took 1 shot each. So finally, we might want to just select the goals themselves. So this is what these couple of lines of code do. So what it's doing is basically selecting subtype if the string contains dash goal. So let's just run this piece of code. And so we can look at home goals, and you can also just print out home goals. So, I mean, one of the other things we of course want to do is take a look at create some visualizations of these shots and goals and see where they occurred on the field. And so here, what I'm going to do is just begin to look at the visualization module that I put together. Obviously, the first thing you'll want to do is simply plot a pitch. If you look into Metrica Viz, there's a function here called plot pitch. It's very, very similar to the one that you saw with David. It uses matplotlib, which is one of the most common graphical and plotting tool modules in Python. And just skimming through it, it creates a figure window. You can set some of the colors, and then you have the some of the dimensions of the field, which you can pass it as a parameter as well. So let's just run that and create a pitch. There we are. It's nice green with white lines and a little bit of a border. And so the next thing we might want to do is simply just plot some of the shots on this pitch. So you can see we've passed back this sort of figure and axis handle, and this allows us now to basically sort of superimpose other data onto that figure. So let's look at the home goals. We can see here that the first home goal occurs at index 198 in the data frame. And so we can essentially plot the start positions for that event, which is essentially where the shot was taking place. So if you run that, you can see that the plot took place right on the at the edge of the 6-yard box. Now the nice thing is about the data here is it also gives you not only the start position of the shot, but the end position of the shot, so basically where the shot went. And we can plot that instead of as a single point as an arrow. And so the matplotlib function for that is annotate. This is the line of code here. And what you can see now is we have an arrow, and you can see that the shot went in by the near post of the field. And perhaps we want to plot some more information than that. If we look into the event data, we can sort of see what happened in the run up to this goal. So let's just look at the events. Now we know the goal occurred at index 198, so let's just scroll down to there, get rid of the colors. So here we have is the goal for the home team. And so you can see that sort of the preceding events were sort of a sequence of passes. They recovered the ball from the away team with a tackle, and then about 8 passes before they scored the goal. So maybe we want to be able to plot the whole sort of sequence of play that led up to that goal from the point at which they reclaimed the ball. And what I've done to help us do this is create a little function called plot events that allows you to very quickly plot sort of a whole sequence of events one after the other. So this is again part of the Metrica Viz module. Let's scroll down. Here it is, plot events. So what this does is you pass it an events data frame, and then it goes through each row in a for loop here. It goes through each row, and it'll plot a marker at the start position of the event. And if you want, also an arrow that sort of marks where the end position of the event is, and that's obviously quite important for a pass. And so what we'll do is we already have a figure with a shot on, so we'll just overplot the passes that led up to that goal onto the same figure. So what we're going to do is, if we go back to the event data, we can see that let's go back to row 198, index 198. So you can see that the first pass in this sequence is index 190. So we're just going to plot all 9 events from 190 to the goal at index 198. And so let's just plot this line of code here. So as I said, you're going to plot events 190 to 198. And as we want to overplot this, what we're going to do is set this figx parameter to the handles of the figure that we've already created, which we do like this. So let's run that. And now you can see we have this whole sequence of passes. It's a little hard to tell exactly where the passing move starts, because obviously the event data doesn't include periods in which a player ran with the ball. But what you can fairly clearly see is that in the passes that led up to the goal, there was a pass out to this player here, and a pass out to the player that finally scored the goal. And one of the things, of course, we can annotate this information as well and add a little bit more information, figure out who the players were. So let's rerun this line here, but what we're going to do is get rid of this. So it creates a new figure, and then Tate equals true, add some text to the figure 2. Right. So here you can see now that each label is, each pass is labeled with the player, is indicative of the type of event it is, in this case pass, and the player that made the pass, player 8. So you can see here it's clearly a pass from player 8 to player 1, and then to player 10 who scores the goal. So now in the next part of this, what we're going to do is to look at reading in the tracking data and make some simple plots from that, and then finish off by showing where all the players were in the shots that we just looked at. So as we saw before, there are 2 tracking data files, one for the home team and one for the away team. And I've written a little function that reads in the tracking data. So let's look at how that works. It's in the Metrica.io module. And here it is. And so this is a function that takes, again, the directory of where the data is, the game ID, and then the team name, which in this case is either home or away. So let's just run this line of code and see what the tracking data in the data frame looks like. So let's go ahead and run these lines of code. Let's put them in here. So reading the home team, the away team. Let's look at look at what we've just read in. If we add the shape, you can see that there's 32 columns of data and about 140,000, just over 140,000 rows. And that's not a surprise, because if there's 90 minutes in seconds, multiply by 60 to get into seconds, and then we've got 25 observations of player positions a second, and so you can see here that's about 135,000. And then we've got some information from before and after the game as well. Let's look at what this looks like in the variable explorer. So what you can see now is that there's the index, this is sort of the frame ID, the period, which is the half, so it's either 1 or 2, and then the time at which the observations were taken, and this is in seconds. So this is the positions of all the players after 40 milliseconds. And then following that, you have 2 columns for each player. So this is player 11, X position, Y position, player 1, X position, Y position, and so on. And if we scroll right to the right, you'll see that some players that don't have a position, and these are the substitutes. And so eventually they'll have positions when they were brought onto the field. And finally, we have the ball positions, and these are missing because the game doesn't start until some frames later, in actual frame 51. Now, as you may have noticed, again, as with the event data, the positions are all in this sort of native coordinate system where the field goes from 0 to 1 in both length and width. And so we can apply exactly the same function that we used earlier to change the coordinate system for the event data for the tracking data as well. So this will basically moves from the coordinate system of the data to coordinate system where the origin is in the center of the field and all the distances are in meters. So let's run that too. Take a quick look at the tracking data again, and now you can see all the player positions have changed such that they're now essentially in all in meters relative to the center spot. Okay, so now let's look at plotting some of this data. So let's start off by plotting a blank pitch, as we did before. So here's our field, and now we're going to overlay the positions of a few of the players over the first 60 seconds of the data. And so 60 seconds, remember that we get 25 observations of players' positions per second. So 60 seconds corresponds to the first 1,500 frames. So this line here plots the x plots the positions of player 11 for the first 1,500 frames. So you can see this is home 11x and home 11y, so the x and y positions, and we'll color this player with a red marker. So let's plot that onto the football pitch that we just created and take a look at what that looks like. And this is clearly the goalkeeper. So, moving around penalty area, it could be her penalty area over the first minute of the game. And you can see here, these dots spaced out here means the goalkeeper was essentially moving really slowly. Let's look at another player. Again, over the first 60 seconds, let's look at player 1. Let's overplot that. So here you can see, so the player, this is probably the starting position. Looks like a defender at the beginning of the game, made a run back towards his own goal. And let's plot now some other players. Let's plot so players 2, 3, and 4. See who these are, all the different colors. Right, so here's the traces now of these other players. And so, what it looks like is the 4 defenders. So the left back, 2 center backs, and a right back. And one thing you'll notice is they all have this kind of similar shape to their trajectory. So again, this player, he sort of loops around here. This defender again loops around here. This player also makes a loop, and this player also makes a similar kind of loop, and then end up with runs back towards their own goal. And this is, of course, because teams tend to try to retain their formation. They move around as a block. So there should be some equivalence to the pattern their trajectory makes as they run around the field. So now, instead of looking at a player's trajectories over time, why don't we look at their positions at the moment of the kickoff? Now, as we saw before in the event data, the kickoff is itself an event. It's the very first event. And one of the nice features of the Metrica data is that it is perfectly synced with the tracking data. So one of the columns in the tracking data is the start frame, and in some cases, like for instance, such as a pass, the end frame. So this tells us exactly which index to look for in the tracking data if we want to plot the players or find the player positions at the moment that that event occurred. So this is telling us that there's a set piece that obviously was a pass between 2 players, and it occurred in start frame 51. So all we have to do now is plot all the positions of the players in frame 51. But of course, to do this, you need to loop over many players in the frame, or we need to separate the x and y coordinates of all the players in the frame. So we have again a special function to do this. Let's take a look at it. So it's called plot frame. You pass it the home team positions. This is a row of the data frame. The away team positions. And then essentially what it does, beyond sort of creating the pitch, if you didn't give it a pitch already, it looks for all the X columns or the column headings of the X positions. So it's looking for anything that ends in _X, except for the ball. And the Y column, again, the Y positions, anything that ends in _Y. And then it plots the positions of all those players with those column headers. And then you can see this loop here, it sort of loops over the team. So we've set up a little list with the home team and away teams, so it does all the home teams first and the away teams first, and you can set the team colors, which in this case the default is red and blue. And then it's a little bit further down, you can see there's a second part of this which says, you know, if we decide to include the player velocities, we haven't calculated the velocities. That's one of the topics for the next lesson in the series. So you can see the functionality for plotting velocities as well as positions is already in that, and I'll show you next time how that happens. And then finally, the last thing we do is plot the ball X and ball Y positions for this frame. So let's run that on top of the. Let's create a new figure and run that. So again, here you can see now we're sort of accessing index 51, which is the moment in which kickoff occurred for both the home team and the away team. So run that, and here we are. That all looks very sensible. So the red dots are the home team, shooting from right to left, and the blue dots are the away team from left to right. As we saw in the event data, it's the away team that kicks off. The ball is this black dot here with the player who's standing in the middle of the center circle. And you can see some other useful information here. So for example, the red team starts off by defending, and they're in a pretty clear 4-4-2 formation. Here are the two forwards here. You know, it looks like the blue team are also playing with a 4-4-2 formation. As these four here, the wingers have started out very wide, and here are the two forwards, with one of them taking the kickoff. But on the topic of formations, you know, we wouldn't want to just rely on the formations at kickoff. We want to use as much of the tracking data as we can to measure formations, and that again is going to be one of the topics in the next lesson. Okay, so let's just finish off this by looking at the player positions during the first goal. So we know, as we said before, we know that let's look at the first home team goal. It occurs index 198, which was minute after in the 8th minute of the game, or after 8 minutes. So again, let's plot that event using the plot event function. So this should here just plot the final shot. I've only asked it, so I'm only looking at event index 198 here, not the preceding passes. So that's why we've just got the final shot from player 10. And now, you know, what frame did that occur in? So we want to find the index of the tracking data such that that corresponds to the moment that shot was taken, so that we can get the positions of all the other players. And so we can look at in the event data, we can look at index 198 and look for the start frame, which this case was this number here. So let's put that in a variable called frame. So frame is again that's that same number, and then use our plot frame function to plot the player positions, and we want to pass in to that the figure that we've just created with the shot in it, such that we overlay the positions onto that. Okay, so this takes the row is given by this frame here, and we run that. Okay, so let's look at what we've got. So now, you know, rather than just having the location of the shot plotted, we've got the positions of all the players, and so we could got a lot more context about, you know, the situation in which the goal was scored. And we can use all this information now to understand things like how much pressure the shot taker was under, and if we look back, you know, in the preceding passes, you know, exactly, you know, what was the key critical moment, what was the critical pass or the critical run that made this goal possible. And these are all things that we're going to look at in more detail in the next couple of lessons of this course. Okay. So that's the end of the code demo for this lesson. So the next thing is I'm going to leave you with a little bit of homework. So based on the code that I've shown you already, I've got 4 tasks for you here. Download the data from the Metrica repository, and I'll put the link up to that again at the end. Look at the code that I've just shown you from the Friends of Tracking repository. And then the first task is simply to plot all the passes and shot that lead up to the second and third goals of the match, you know, in a similar way to how we what we did for the first goal. Plot all the shots by player 9 of the home team, and try to use a different symbol for shots that resulted in a goal. So use one symbol for a shot that didn't result in a goal and a different symbol for one that did result in a goal. Plot the positions of all the players at player 9's goal, similar to what we just did for the first goal. And then the final task, a little bit more advanced, is to try to see if you can calculate how far each player ran during the match from the tracking data. And you can tweet any of your answers or any of the plots that you make to hashtag FOT, Friends of Tracking. And that's it for part 4 of our Friends of Tracking hands-on football analytics series. And I'll leave you with the links to the data and the code from today.